So now, this question, like cellular adaptation to injury. Basically, we are looking at four derivatives over here. Now, what the question means is that when one sustains an injury or when there is any predicament to any part of the body, the way the cells of the body responds to it, that is basically what the question seems to achieve. And when we talk of cellular adaptation, they are the changes that the body assume, or the cells and tissues of the body what assume in response to what an injury. So like Maxwell cited an example, when there is a break in the continuity of the skin, there should be some mechanism to bring about what healing, and definitely there will be what cell proliferation, and there will be what also something you call there will be apoptosis, that is dead cells will be eliminated and new ones will be formed. The opposite is tissue necrosis. All this will happen. Also, let's say there is a cut, there should be some mechanism for what the cut to what to heal. Or let's say the person is bleeding, there should be some mechanism for what the clot, there should be mechanism for the cut to clot, the bleeding to stop. And it goes through processes. So there should be an exposure to sunlight, which will cause the skin to produce what fibrin. In response to what the sunlight, the fibrin will bring about what release some hormone we call fibrinogen to aid in what the coagulation. But when it comes to cellular adaptation, we have four things that we look at normally. We have atrophy, we have hypertrophy, we have hyperplasia, then we have metaplasia. Now, when we talk of atrophy in layman's understanding, atrophy is a decrease in the size of what a cell or a tissue, or a muscular decrease in the size of what a tissue. Let's say there is a particular part of the body that has not been used for a particular long time. That particular organ shrinks in what? In size. So example like the penis, like this. Example like the penis. If you are not using it, even though as you grow there's enlargement of weight, but then when there is any organ of the body or there is any muscle of the body that has not been used for a long time, that particular cell or tissue become what necrosed. That means it dies. There will be failure of what oxygen rich blood being supplied to that area. So let's say a child who is born, you see, when you give birth, what they do is that they tie the cord. Now when they tie the cord, they are depriving what that particular place that was tied from what oxygen. Now as it keeps on being deprived of oxygen, that particular portion dies. So with atrophy, there is what a decrease in the size of what an organ, or let's say a muscle, because it has not been used for a long time. Then the hypertrophy is the opposite of it. Normally the hypertrophy, that is there has been an overuse of a particular part of what the body. So let's say example like the heart. When the heart beats abnormally, it becomes hypertrophied. That means it increases in size. So all the chambers will increase, causing what an abnormal pressurable flow of what blood through the chambers. So hypertrophy is an increase in size of what an organ or a muscle that is due to what an overuse of that particular organ. And atrophy is the opposite, that is a decrease in the size of it. Hyperplasia, that one, it deals or it talks about an abnormal increase in size of what a cell. You see, the body is made in such a way that everything in it should be balanced. We have something we call a mass volume. When you are looking at the mechanisms, feedback and the feedback mechanism, you have something called mass balance. Now everything in the body should be balanced, so one shouldn't go up more than the other, and one shouldn't be more down than the other. Example is like the glucagon and the insulin. In the year mode of operation, insulin shouldn't be much in the body. The same way glucagon or glucose shouldn't be too much in the body. So the insulin is there for the pancreas, is to make sure that there will be what a production of what insulin to regulate what the flow or the circulation of what sugar content in the blood. So one shouldn't go up than the other. one should always be there to check the other, the activity of the other. Now in hyperplasia, there is what? An abnormal increase in size or in an abnormal overgrowth of what? Cells or what? Tissues. So example like the breast. The breast, they are having tissues there. We have adipose tissues, we have melanocytes and other tissues over there. Now, all the tissues there are, or and the cells there, they are in their normal quantity. Now, when they become what? An overgrowth or an increase in the size of that particular cells, they will get what you call what? Hyperplasia. And normally it can lead to what? Cancer, either benign or what? Malignant. So when there is an overgrowth of a particular cells, and they are there for a particular long time, they metastasize and spread and become what? Overgrown. So that one is an abnormal case. And with and for the last one, a dysplasia. Dysplasia is when there is what? An abnormal changes to the structure of what? A cell, or when you take the morphology of the cell, either red blood cell, either the blood cell, either connective tissues. Tissues is a group of what? Cells or collection of cells. When there is what? An abnormal may change to the structure or the morphology of that particular cell, that's where we get all the dysplasia. So let's say example like the red blood cell, in the situation where we are having sickle cell. Now, instead of the oval shape of what? The blood cell, or the biconcave shape of what? The red blood cell, it becomes what? Crescent, like a moon shape, or the sickle shape. Now, when it comes like that, that means the shape, the original shape of the cell has been distorted. And in that case, it's what? It becomes debilitating to the body. So we call that one dysplasia. That means there has been what? An abnormal changes toward the structure of what? The cell. And this comes about when there's what? Differentiation. Now, when you consider this topic, immunology, we have some mechanisms, cytokines, we have interleukins and other B cells in that aid in maturation of some parts of what? The body, or some organs of the body. Now, all these structures undergo what we call differentiation. So before they can move from one particular stage to the other, they become differentiated. Now, during their differentiation model, what happens is that there could be what? A mutation towards a particular process, and when that particular process becomes mutated, it can result in the abnormality towards the shape or the morphology of that particular cell. Let's take sickle cell for instance. Now, sickle cell is a codings of what? Amino acids. That gives what? The normal structure for amino acids. Now, we have about 8 amino acids that code for what? Hemoglobin. Now, what brings about sickle cell is that there is a particular amino acid called valine that replaces what? This amino acid, glutamate. Glutamate supposed to be on the 6th position in the structure, the complex structure of what? Hemoglobin. Glutamate is supposed to be on the 6th position, but then valine replaces the glutamate in that 6th position, causing that abnormal structure that we see in what? The sickle cell people. So it is physiologic, then it manifests. So during differentiation that we get such a case. So when it becomes like that, we say that the cell has become what? It has been dysplasia. That means the normal morphology of the cell has been distorted due to what? Inappropriate differentiation to bring about what? A different what? Organ, or the maturation of a different what? Organ. So basically, that is that in a layman's understanding. But I think when you look at immunology, you can understand it. Cell mediated immunity, then humoral immunity. Talking of the cytokines, the interleukins, and those kind of things. Okay, so metaplasia is normally a reversible change in which one differentiated cell type is replaced with another differentiated cell type. Normally, is seen in cellular adaptations to injury or stress. So let's say, for example, when you take the respiratory tract, now when there is chronic irritation to this respiratory tract, it can go on to extend that the normal ciliated epithelium tissues or cells of the respiratory tract will be replaced by squamous epithelium
which is more resistance to what chronic irritation. So in that case, one cell type has been able to change to another cell type to withstand what the stress or what the injury as what a defensive mechanism. And so basically, when we talk of metaplasia, that is it, when there is a reversible change in a differentiated cell being replaced with what another cell due to what cellular adaptations to stress or what injury.